I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
Medicine.
nature,
Space. Time.
Brain.
Life. The universe.
This week, is anybody out there? Or are we alone in the universe? We ponder one of the fundamental questions of humanity, from flying saucers and UFOs to why we haven't found any evidence of aliens, and what would it mean to find them? I'm Greer Jackson, and this is The Naked Scientists.
The Naked Scientists podcast is powered by ukfast.co.uk.
Now, picture this.
You're out walking the dog. It's late afternoon and getting dark. In the sky, you see a bright light. Is it moving? You think so. You try and think what it might be, starting with the most likely. Aircraft landing light? Venus? Foil balloon reflecting the light? Iridium satellite flare? Could it simply be floaters in your eye? You're close to the nearby military base. Perhaps it's an exotic aircraft, or one of those drones we hear so much about these days. Suddenly, it dawns on you. Of course! It must be an alien scout craft from the Zeta Reticuli star system, piloted by 3 telepathic greys with the tacit approval of a clandestine Majestic 12 US government group. It can only be a matter of moments before you're abducted, after which you'll experience a feeling of paralysis, suffocation, missing time, and pain around the genitals. You will retain no memory of the event, except during regression hypnosis, after which you'll discover a small metal implant on the nape of your neck. It's bound to be one of them. Your dog barks excitedly at you in agreement.
Dallas Campbell.
Science broadcaster, television presenter, reluctant writer.
Perhaps not so much of a reluctant writer when it comes to conspiracy theories, though. The segment Dallas read is from a chapter in a new book called Aliens, in which he charters where all these conspiracy theories began.
As long as human beings have been roaming the earth, there's been conspiracy theories. The point is, I think we all are conspiracy theorists, just to various different degrees. We all have probably irrational beliefs that we justify in the secret ways that we justify beliefs. But the modern story of flying saucers began in the 1940s.
What happened in the 40s? What was this initial sort of spike in interest?
So Kenneth Arnold was a civilian pilot who was out flying above the mountains in the northwest America. Thought he saw something, reported seeing some bright flashing light, which he described as being like a saucer if you skipped it across the water. And the press picked up on this. And of course, this is during the Cold War, general paranoia about the Soviets. And suddenly this term flying saucer was cottoned onto.
What was it? Well, nobody quite knows. It was investigated by the Air Force at the time, and their report was a bit of an oxymoron. They concluded that Kenneth Arnold was both a credible witness, but what he saw was a mirage. The pandemonium wasn't limited to the States, though. 3 years later, the UK's Ministry of Defence set up one of the best-named scientific studies I've ever come across. The Flying Saucer Working Party. The MOD's chief scientific advisor, Sir Henry Tizard, insisted that UFO sightings should not be dismissed without any scientific study. Their report, published in 1951, argued that all such phenomena could be explained by balloons, birds and blimps, illusions, delusions and hoaxes. Oh, and weather. They concluded,
We accordingly recommend very strongly that no further investigation of reported mysterious aerial phenomena be undertaken, unless and until some material evidence becomes available.
From then on, it went crazy. People started seeing flying saucers everywhere. And of course, from 1947, of course, we have Roswell, which was the modern culture today is still the poster child of flying saucer conspiracy theories. That and Area 51.
I know Independence Day, that film, was based at Area 51 or based around that area. And I remember seeing this aged, I think I was about 12 or 13 at a sleepover. And I was so frightened by the scene where I think an alien gets pressed up against the glass or they press up a dead person against the glass.
Right.
And I vomited straight into my lap and was sent home.
Seriously? That's wow. That's. I remember I watched The Exorcist aged about 12 or 13, and I remember having a similar reaction at the moment where she vomited in The Exorcist, and I had a similar reaction, but not in Independence Day. It's quite tame Independence Day.
I think it's
quite
only
ludicrous.
a 12 as well.
I think so. Maybe you had a stomach bug as well. Maybe it was a combination of
Blame it
aliens.
on too many sweets, maybe, at the sleepover.
Or maybe you've been abducted and the memory has been repressed, and somehow that triggered a feeling.
Maybe.
Could it have been that?
I mean, possibly. Did you have this lump at the back of my neck? Come to think of it, could it be a metal chip?
It could be a metal implant.
It would explain my irrational fear of a film, which, even after 15 years, I still haven't watched. Returning to the mysterious place that's Area 51, though, what do we know about it? Wikipedia says it's a United States Air Force base in Nevada, but what goes on there? Nobody really knows. After a Freedom of Information request, documents revealed that in the 50s and 60s, surveillance aircrafts were developed there. But otherwise, we know very little, and it's this intense secrecy surrounding its purpose. I mean, the CIA only admitted the base even existed 3 years ago, that has made it absolutely legendary in the world of UFO sightings.
I've been to Area 51 a few times, and there's a wonderful sign as you approach. It's called Groom Lake Road. You go off the main 375 highway and you drive down about 13 miles, this dead straight dust track, and you get to a turn in the road and there's some hills, and beyond those hills is the actual base, and you can't actually see the base, but you come to a sign, and of course the exciting bit about the sign, it just says use of deadly force authorized. And if you go past that line on their own, they are quite within their rights to shoot you if they want to, and nobody will have to answer any questions or justify it. And then, of course, you want to go past the line. And the exciting thing is, just on the hills at that junction in the road, you can see these white Jeep Cherokees, and they're just sitting there watching you with binoculars, waiting for you to go past. The reality is, though, if you do go past, what tends to happen is they come out and stop you, and they give you a hefty fine and send you on your way. I don't think anyone has actually been shot, but it's all the technology that goes with it. It's the motion sensors, it's the drones, it's the Jeep Cherokees, it's the exotic signage. It all adds to this wonderful conspiracy theory story that behind that line lurks the aliens.
Did you dare cross the line?
Yeah,
when you went?
no. Well, I've always been really interested in UFOs just from a sort of cultural point of view. I like the sort of UFO folklore and the subcultures that surround these stories. Of course, people see things in the sky all the time. Are they aliens from outer space? No. I think with a high degree of certainty, we can say that they're not that.
Having said that, some do believe it's true. In fact, Hillary Clinton had pledged to open up government UFO files. What does Dallas think we would have seen, though, had she won?
I think that the reality, we like to think, because there's a lot of files that have been released. There's all kinds of big chunks of files that have been released. And of course, there's nothing in them. There's nothing of any interest in them. The exciting thing about unopened files is the fact that they're unopened. As soon as you open the box and realize that they're actually really, really boring, and there's actually no evidence of aliens whatsoever, and the fact that Area 51 is just a secret military base where they test exotic aircrafts, everyone will be very, very disappointed. That's the reality.
Would you want to know, that being said? I mean, kind of it's the mystery that we enjoy in itself and all the stories that go around it. I'm thinking the knock-on effects in culture. There's all that enjoyment that surrounds it.
You're absolutely right. It's the not knowing. It's the fact that you will never know because it's untestable, it's unprovable, it's unfalsifiable. You can never prove the ET hypothesis. And that's exactly right. It's exactly what makes it so tantalizing. The fact that you can never disprove that aliens landed at Rendlesham Forest or Roswell or Area 51. It's untestable. And of course, that's what people like. They love that sense of mystery, that excitement, that there is agency beyond what we know. It's that sense that we have of something else being out there is all wrapped up in those stories. And it's great for popular culture.
Perhaps then it's best left a mystery when it comes to alien visitations. But what about the possibility of life beyond Earth? Well, to get to the bottom of that, we probably need to know what life is.
It is notoriously difficult to do, and actually I think it's almost pointless to try to define life. I mean, there's hundreds of definitions of life out there, and they're all wrong in one way or another.
OK, maybe not then. This is Nick Lane. He's a biochemist at UCL and is a bit of an authority on the origins of life here on Earth. Perhaps then it's best to think about what life does rather than is?
Problem is that life is really a continuum from a non-living state to a living state, and there's all kinds of intermediate stages. So is a virus alive or not is a question which is often discussed. It's really what life does rather than what it is. And in all these cases, life is making copies of itself, and it's using the environment to do so. So one of the problems with most attempts to define life is that it excludes the environment. All life parasitizes the environment in one way or another. So plants do. They require sunlight, they require carbon dioxide, they require water and so on. That's all they require. We parasitize the environment a lot more. We go around eating plants and so on. But essentially all life is parasitizing an environment which is providing it with its energy needs to make copies of itself. So I think you'd say there are about 6 different things that a cell requires. It requires a carbon source to make more copies of itself. It requires energy to bind things together, to make polymers and to produce more cells. It requires excretion. You've got to get rid of the waste products and the end products to drive reactions in a forward direction. There has to be some form of compartmentalization, a cell-like structure that makes the inside different from the outside. There have to be catalysts, the beginnings of biochemical reactions, and then there has to be some form of replication. Now, I think those are the 6 properties of life that we really need to look for.
Now we have 6 things needed for life, but it took a long time for it to come about on Earth.
Well, we don't really know. There's a lot of arguments about it. A kind of glib answer would be about 4 billion years ago. There are fractionated isotopes of carbon and so on in ancient rocks from about 3.9 billion years ago. There's a lot of debate about whether that signifies life or not. But I think most people think, on balance, it probably does. I think we'll never know exactly how life started on Earth. But what we can know are what are the principles that lead to the origin of life from a non-living environment. I think there's actually a good argument to say that life could end up, at least at the bacterial level, remarkably similar. I mean, there's a strong argument to say that carbon is really better than anything else. It's much better than silicon, for example, at forming, complex bonds between molecules. And it's also available, carbon is far more available in the universe than silicon. And also there are gaseous carbon oxides, carbon dioxide and so on. It's like a Lego brick, whereas silicon oxides are, sand and so on. You can't really bootstrap yourself up from the ground with sand. You can't build on sand.
So if we're looking for life elsewhere, then it's likely to be the same. That's because the rules of physics and chemistry are universal, and therefore exactly the same constraints will exist wherever you live in the Milky Way, or even in the Andromeda Galaxy. To Nick, then, it's likely you're going to end up following the same sorts of evolutionary pathways.
I think, yes, it's possible. We can conceive that life could have operated in different ways. But if you think about the probability of finding life, carbon, water, the kind of rocks that are required for hydrothermal systems and so on, they are all very common. So the kind of life that we have here is likely to be the kind of life that we find elsewhere as well.
It's The Naked Scientists, with me, Greer Jackson. And today, the search for extraterrestrials. Are we alone in the universe? Now, as Nick has just mentioned, in order to be considered alive, you need to parasitize your environment, make copies of yourself, and then excrete stuff. So could we track the elements that cells excrete? This metabolic activity? A bit like a biosignature. Here's Jim Al-Khalili, Professor of Physics at the University of Surrey.
So, certain types of organic molecules or the presence of oxygen or isotopes of carbon. There are certain chemicals that don't occur naturally, that can only be created by living organisms.
That's all very well, but the Andromeda Galaxy is far, far away. It's our nearest neighbour and yet is still a whopping 2.5 million light years away. So let's stick to our patch of sky then. How are we looking for biosignatures around stars, say, 100 light years from home?
My name's Carol Haswell. I'm an astrophysicist at the Open University where I do research on exoplanets.
Exoplanets are just planets outside our solar system, exo being Greek for outside.
As a very young child, I knew that I wanted to be an astronomer, and like many young people, I thought that I wanted to do cosmology just because that seemed like the ultimate thing to do. And then I think as I got older and actually started studying at university, then I realised that actually cosmology seemed to me to be a little bit abstract and removed from things that I could identify with. And so at that point, I decided that I wanted to work instead on things closer to home. So I, in fact, started my research career still doing something that's quite far out. I was working on accretion around black hole binary star systems. And I did enjoy that. But in about, I think it was 2003, I saw a paper which had observed an exoplanet using the Hubble Space Telescope. And when a planet passes in front of a star, from our point of view, it blocks, say, 1% of the light from the star and produces a very subtle dip every time it goes around the orbit. But this particular paper, they had used the Hubble Space Telescope to look in the ultraviolet, and they had seen, instead of a 1% very subtle dip, a 15% diminishing in the light from the star. And this told us that the planet was actually surrounded by a huge cloud of hydrogen. And at that point, I just thought, this is just too exciting, and exoplanets are the way to go.
I mean, obviously it had a profound sort of importance for you, but what was the importance of that discovery more generally in the scientific community, I'm thinking?
What that paved the way for was the whole field of being able to actually assess the chemical composition of exoplanets. So here you have a planet orbiting a distant star, and because the planet is surrounded by some gas which is translucent. The gas is made up of atoms and ions which absorb light at particular wavelengths.
I think of it like looking at a rainbow. Whilst hydrogen may block one frequency of light, red let's say, methane might block green. So you have a rainbow or a spectrum of light that might go and yellow and pink and purple and orange and blue. And by looking at what colours are missing, you can work out what elements are found in the atmosphere of this extremely distant planet.
So it really opened the field for being able to actually measure what planets outside our own solar system are made of, or at least what their atmospheres and the surrounding gas cloud is made of.
What I find absolutely insane is that these exoplanets are a long, long way away. I mean, how far are we talking in light years?
Well, the very, very closest star is about 4 light years away. And obviously, most stars are very much further away than that, hundreds or more light years away. So the transit method has found thousands of planets or planet candidates. Not all of them have been completely verified, but it's been extremely successful at finding planets.
The closest star to us, the one that's 4 light years away, is called Alpha Centauri. And Carol's colleague, John Barnes, discovered an Earth-sized planet orbiting around at the right distance from the star for liquid water to exist. It's called Proxima b. I tweeted Carol when the news broke to see if she could use her transiting technique to see what the planet's atmosphere is made of. But sadly, there's only a 1% chance of Proxima b transiting. Regardless, scientists independent to the study described it as thrilling because it's close enough for us to send our first interstellar spacecraft. However, finding exoplanets in habitable zones doesn't mean we've found life.
It means we've found another planet which we think could be like Earth. It might be at the right distance from its star so that water can exist in liquid form. It might have an atmosphere, and therefore it could potentially harbour life.
Jim Al-Khalili again. To confirm if life does or doesn't exist then, we need to physically go there, or at least send a robot. And the closest place that's been so far is Mars.
We don't believe there's life on Mars now, of any form. But there is a strong possibility that Mars did harbour life billions of years ago, Mars was much more like Earth. It had an atmosphere. The climate, as it were, was a bit more conducive to life. It was warmer. So life could have existed there, and the jury is still out on whether life exists. I do remember back in the 90s, there was a huge surge of excitement when it was thought that we'd found evidence of fossilized microbes in a meteorite that was discovered on Earth that we believe came from Mars. And studying it under an electron microscope, it was thought that they could see these fossilized remains of a little organism. And that made headline news around the world. But then, of course, they realized that, no, actually that was some inorganic crystalline structure that could have emerged without any evidence of life. So that was a huge disappointment.
But getting to the red planet will be tricky, and that's largely because of the daunting conditions of space, but also the amount of time you're out there. 9 months if you're heading to Mars. NASA astronaut Stanley G. Love spent 2 short weeks in space, and it was enough to play absolute havoc on his body.
Left Bravo, right Juliet, both short of Zulu.
You get strapped in 2.5 to 3 hours before you launch. So you have plenty of time to think about whether that was really a good idea.
What was going through your mind?
Well, the usual 2 sort of astronauts' prayers were, the standard one is, I really hope I don't screw up. And not everybody admits it, but many people are also hoping they don't get blown up.
6, 5, 4, 3, 2, 1.
Launching from the ground to reaching orbit takes about 8 minutes. And during that time, there are milestones that you're sort of checking off, places where you say, okay, from this point on, if we lose an engine, we're going to fly across the Atlantic and land in Africa, whereas before that, if we'd lost an engine, we would have tried to turn around and land back in Florida. There was also a milestone that my commander read off to us over the headsets. He made a little congratulatory statement for us rookies on board, congratulating us on making it to space and officially becoming astronauts. And when the engines cut off and you're floating in orbit, that's 40% of the risk of your entire space mission has just been retired in those 8 minutes. So you get a good feeling thinking, this just got about twice as safe as it used to be when I was sitting on the pad 8 minutes ago. So that's a great feeling. Floating in your straps is just amazing. And then the next thought to hit you is, it is now time to get to work.
Paint me a picture of life in space. I imagine microgravity plays havoc on all sorts of things in terms of how you sleep, but also how you eat and shower.
Shower? Who said anything about showers?
Oh, blimey, 2 weeks without a shower?
Well, imagine turning off the gravity and turning on the shower. Water would go flying everywhere. So if you want to take a bath, it's going to be a sponge bath. But you're right. Daily life really has a lot of changes when you're in microgravity, especially at first when it's disorienting. I mean, there's a few fun aspects, especially after a couple of days you get used to it. So you can actually put your pants on both legs at the same time in microgravity. But getting into bed, setting up a bed, takes a long time. You're setting up a sleeping bag, basically, that's attached to the wall or the floor or the ceiling, if you like. Changing clothes is hard. Eating is hard. Most of our foods are in sort of packets, and you kind of cut open a corner and kind of nibble, or if it's a liquid stuff, you can kind of suck the contents out. But it just takes a long time to get anything done. Going to the bathroom can take half an hour, especially the first couple of times. The biggest surprise on the whole flight for me was not during the flight, but after landing. As your system gets used to being in gravity again, you can be very dizzy, like your head spinning. And I didn't quite expect that. I expected some of the other effects to feel kind of weak, maybe sick to my stomach. I did not expect to be dizzy. But in general, we were very, very well prepared for our flight. And folks who had been there came back and told us about their experiences, so there were not very many surprises.
You're mentioning the effects of microgravity there, and there's lots of talk about the effects on bone density and muscle wastage. Was this something you encountered after 2 weeks when you returned back to Earth?
Absolutely, but I was a bad astronaut and I did not do my exercise. But I had ample time to regret that when I came home. So I lost 8 pounds of muscle, almost all out of my legs. If I went again, I would not blow off my exercise because it made a huge difference. And that was only 2 weeks. You can imagine if you were up there for 12 times longer than that, being up there for 6 months.
How long did it take you to recover those 8 pounds of muscle?
Several months. I have this memory of being finished with the spacewalk, waiting outside the airlock to come back inside, and our shuttle's orbit took us up over the Pacific Ocean and across the western part of the United States, and just having that immense tableau of scenery of all the world that I'd known growing up, and having that just come rolling up underneath me as we were finishing that spacewalk and feeling good about it. That was a wonderful, wonderful experience, and something I'll remember for the rest of my life.
It sounds beautiful.
It is. I like to say, and this is a strong statement coming from somebody with a background in astronomy, that the Earth is the most interesting thing in space. So I'm hoping that in the future more and more people can see what it's like to be in orbit, look down at the Earth, see what it really looks like, and observe our home as a planet rather than just as something you drive around to work and back every day. And I think it will make us all better people to have that experience.
Stanley's description of it already makes me feel slightly enlightened. But if there's anything to take away from his story, it's that it may be best to send a robot to do the dirty work, at least initially. The European Space Agency is doing just that with its ExoMars mission. It sent out an orbiter and a rover. Actually, you may remember in the news from last October when their practice rover crash-landed into the surface of Mars. Despite this rather expensive fluff, they have got funding to carry on with their plans to launch the real deal in 2020, fully kitted out with a drill and a suite of instruments dedicated to see if life ever existed on Mars. I went to meet a prototype of this rover called Bruno and his owner Paul Meacham from Airbus Defence to talk about the difficulties of getting Bruno's big brother and humans to the Red Planet.
Mars is not the easiest place to get to. I mean, it's actually very demanding. Even just getting off the surface of the Earth is difficult because our gravity, it doesn't feel very strong to us, but it is an incredible force to overcome.
And then getting there, I imagine, it's 9 months?
It is a very long time, yes. 9 months in cruise, and of course, during that whole time, you're away from the Earth's protective layer. So you're subject to the full elements of space. It's quite tricky to overcome that.
To give you an idea, to get off the surface of Earth, you need tremendous amounts of power.
If you're strapped on top of a rocket, it's not a very pleasant place to be. You are getting blasted with lots of vibrations, lots of sound waves. So you've got to build your spacecraft to be able to withstand all those forces and not transmit too many of them to the actual passengers.
How do you test that?
Essentially, you've got environmental test facilities where you have a big table that shakes the spacecraft. We even have a room where we do acoustic test. So essentially we stick the spacecraft in there and we blast it with sound waves. It's not a particularly pleasant place to be, because if you were a person in that room when we were testing one of our spacecraft, you would be killed.
That's not all. The radiation can wreak havoc on your electronics. In the Apollo missions, something like 3 days in space was the equivalent of 12 chest X-rays.
That's right. They flew through what we call the Van Allen belts, which are belts of radiation that surround the Earth. It's a particularly high-energy environment. But yes, I mean, as you say, that was only 3 days, and we're talking 9 months. So the equivalent dose is much, much higher.
Not to mention temperature.
The rover's main structure is called a bathtub, and it has the space equivalent of double glazing in order to create a thermal barrier through which heat can't get in and heat can't get out. And then when you do that, you can create quite a habitable microenvironment within that cocoon.
And then there's landing. It's not only ExoMars that have struggled to land a rover on the surface. Back in 2003, the Beagle probe famously didn't manage to open its solar panels and power up. What I'm trying to say is it's one big job for people like Paul.
And that's why facilities like the Mars Yard are so important, because it allows us to practice everything we're going to need to worry about when we get to Mars on Earth.
This is the weirdest place I've ever been. I don't know quite how to describe it.
Lost for words I was, but imagine a giant sandpit filled with well, bright orange sand, and a mixture of real rocks and polystyrene boulders. Taped to the walls were vistas of Mars. Bar the lack of weightlessness, the scorching effects of radiation, and the bountiful levels of oxygen, I did feel like I was traipsing around Mars. This is the Mars Yard, and no, it isn't a film set. It's where scientists like Paul test out prototypes of the ExoMars rover.
Bruno has on him all the sensors the real rover will need to drive itself autonomously. That's the cameras and all the sensors in the wheels and that sort of thing. So essentially we practice driving the rover by itself in this Mars Yard.
Can we take her out for him? Can we take him out for a spin?
Yes, we certainly can. Yes.
Am I allowed to tread on the sand?
You can.
And away Bruno goes. Bruno looks like a giraffe. Instead of 4 legs, he has 6 wheels, and the wheels resemble the sort of things you get on tanks.
It was painfully slow going, but hopefully in 2020, when the rover launches for real, one hopes we'll be able to answer the question of whether there once was microbial life on Mars. You're listening to The Naked Scientists with me, Greer Jackson. Now, bacteria is one thing though, but what about intelligent life? Jim Al-Khalili again.
Well, one way is to point our radio telescopes to listen out for signals from space. After all, we've been broadcasting our presence into the universe just ever since we invented radio and television 100 years ago. So whether it's an accidental or a deliberate signal from any alien civilization, we're listening out for those signals. So this is what SETI, the Search for Extraterrestrial Intelligence, is all about. But that's looking for life that has advanced enough to become technologically able to send out signals.
How probable is it then that there is a technologically able civilization that can send out a signal? Well, an American astronomer called Frank Drake had a valiant stab at developing an equation that might inform us how likely or unlikely intelligent life is. Patrick Short, a PhD student at the Sanger Institute, took me through it in a local park.
He didn't intend it to really be his legacy or to be sort of the thing that he was remembered for. It was basically intended to drum up conversation at a conference. And the idea was basically to sort of try to put a rough back-of-the-envelope calculation on what is the probability that we find life somewhere in our galaxy.
At this stage, I think it would be a really good idea to go through Drake's equation to sort of understand a bit more about what these sort of limitations are there. So what is the first item in the equation?
Yeah, so the first item in the equation is the rate of star formation in the galaxy. So they express this in terms of number of stars per year. So the Milky Way is about 13 billion years old, and Drake puts his first estimate at 1 star per year. So that's the first step.
Okay, so 13 billion. Let's write that down.
Yeah. So this would be N star, I guess.
Okay. What next?
So next is what proportion of these stars have planets around them. So not all stars have planets. And Drake put this at somewhere between 1/5 and 1/2. And then we've also got the number of planets per star. So given that it's got a planet, how many does it have in general? And he puts this at somewhere between 1 and 5. Given that you've got a star that's got planets, we'll assume conservatively that it's got 1 planet, and we'll assume aggressively that it's got 5 habitable planets per star.
And when we're talking habitable, we mean the right sort of temperature. It's got an
temperature.
atmosphere.
Exactly.
It doesn't spin too fast or spin too slowly. All these types of things that are needed for life.
Yeah, exactly.
Okay.
Next term.
So we've got number of stars and then how many habitable planets around those stars. So what's next after that?
Then we've got the probability that a habitable planet will result in life. So I guess you can consider it sort of the probability that, given all the right conditions defined by habitable planet, that life will arise on that planet. And Drake puts that at 1, so he's quite an optimist. He says if we've got a star with a habitable planet, then life will arise on that planet. And then this follows quite closely by the second term, which is the probability that that life will develop into intelligent life, which Drake also puts at 1. So he thinks that it's inevitable that if life is created, it follows to intelligent lives.
After this, there's still more, isn't there?
Yeah, so there's then the probability that they develop communication skills. So Drake was specifically interested in looking for civilizations that would have made contact with us or that we could make contact with. And he puts their probability of developing communications at between a tenth and a fifth, so 0.1 and 0.2.
Okay, communications, surely that's the final one.
No, so we've actually got one more. So Drake has factored in exactly how long these communications will last. So we've been doing our search for extraterrestrial intelligence listening, not broadcasting, but only for a few decades. So he places his lower bound and his upper bound on somewhere between 1,000 and 100 million years.
Okay. So if we take this equation and we do the conservative estimate, what do we get?
Yeah, so the conservative estimate, which is 13 billion stars, 1/5 of which have planets, one of which is habitable, and which we develop life 100% of the time, intelligent life another 100% of the time, 10% of the time they develop communication tools, and they only use these communication tools for 1,000 years, then Drake estimates that we would actually have only about 20 habitable planets in our galaxy, which is the Milky Way.
That doesn't seem like very many. What about on the other end of the spectrum?
Yes, on the other end of the spectrum, if you want to go with Drake's sort of most optimistic estimates, then Drake arrives at a maximum of 50 million intelligent species within our galaxy. And again, that's just within the Milky Way. So we've got another 100 billion of these galaxies out there. So even if we pick Drake's lowest estimate, which is 20, then we've got on the order of 2 trillion intelligent species that we could get in contact with.
I mean, that sounds incredibly high. So why the heck have we not been able to make contact with any of these civilizations, or indeed they make contact with us?
Yeah, so that opens up a whole other famous chapter of physics history. So this question was asked by Enrico Fermi. So he's a physicist, and I think the exact terminology he uses, if this is the case, then where is everybody? And his point being that if we accept that somewhere between this conservative and aggressive estimate of the amount of life out there, that surely either we should have heard somebody detected something or had somebody get in contact with us. And especially sort of the extra layer of evidence is that we're actually somewhat young in terms of the history of the universe, right? So if we can imagine our society fast forwarding just a few 100 million years, then we should most certainly be able to colonize the galaxy and do all these sort of intergalactic travels and certainly communication. But the fact of the matter is we haven't heard from anybody. And so the paradox here is if we can accept that the universe is teeming with life, then what are the possible explanations for why we haven't heard from anybody?
Jim Al-Khalili thinks the answer lies in the sheer size of the universe.
Despite searching for so many decades, we are only sampling a tiny, tiny fraction of what is out there. After all, we're only looking towards star systems that are close enough to us, 100 or so, or light years away or nearer. That's only our little neighborhood within the Milky Way galaxy. Just because we may never find evidence of life elsewhere doesn't mean there isn't life elsewhere. I mean, just from the laws of probability, the universe is big enough that it must be teeming with life. It's just whether there's anything close enough to us, but has evolved and become sentient and developed civilizations and developed technology, enabling it to send signals out to us. So there are lots of steps along the way that would explain why we've heard nothing yet.
It's The Naked Scientists with me, Greer Jackson, and today, are we alone in the universe? Why haven't we found any evidence of life elsewhere? Well, half the problem is that the universe is a big place. But how big is big?
Astronomical. That's our word, right? People have used that word to describe how big national debts have been or how large things are, but let me use it in the way it was intended, in the way nature had always planned to use it. The universe is astronomically large. There's no other way to say it.
Meet Neil deGrasse Tyson.
An astrophysicist and co-author of Welcome to the Universe. And as my day job, I serve as director of New York City's Hayden Planetarium, which is part of the American Museum of Natural History.
I suppose it's kind of hard to wrap your head around. So how big is astronomical?
You raise an interesting philosophical point, because normally when we describe our life experiences, we compare them to other things that are of commensurate intensity or size or weight. You'd say, well, how big was that hailstone? Oh, it was as big as a golf ball. So you would compare it to things that already exist in your life experience. But since the size of the universe falls outside of our life experience, there's no easy corresponding thing to say the universe is so big, it's as big as, see, that's the end of the sentence. There's nothing you can bring to the cause. So the way we try to do this is you try to build up from things that are familiar, and you rapidly enter realms that are inaccessible, but you have a thread, however thin, that takes you back to something that you do recognize and that you do understand. And so that's how this basically works. I'll give an example. So if you ask people, if you take a schoolroom globe, it's a foot across maybe, and ask people, if this is the size of the Earth, where would you put the moon? Like, how far away is the moon? People typically put it at most a meter away, okay? But in fact, on that scale, the moon is 10 meters away. 10 meters away from a globe that size. And how far away is Mars on that scale? Well, it is many kilometers away. And you start building and building and building. How big is the sun compared to Earth? Well, if you hollowed out the sun, you could pour more than 1 million Earths into the sun and still have room left over. So, oh my gosh, so the sun is huge. And so this is the kind of exercise you go through, and that gives us some hope of grasping the sheer scale and size of things.
But that's only our solar system. We're talking about the whole universe here. How many galaxies are there? How many stars within those galaxies, planets?
So the observable universe contains approximately 100 billion galaxies. And a galaxy contains upwards of 100 billion stars. And planets, we have come to recognize, are quite common. And when you put in some good estimates, you get about 1.8 billion planets in the galaxy.
Not a small number then.
Yeah, no, yeah, not a small number.
You say 1.8 billion planets. What number of those could be what we consider habitable?
Yeah, so just because you have planets doesn't mean there's life on them. And by the way, this conversation could go both ways. You could say, well, you're not going to have life on all of those planets. Well, actually, some planets have moons, and the moons themselves could have life, as an example. There are estimates ranging anywhere from 1, which is just us, to, I would say, several hundred, some cases a few thousand. But if you're going to be sort of middle of the road conservative, you'd say several hundred civilizations in the galaxy.
Where do you sit on that spectrum yourself? Are you a more conservative estimate, or are you thinking there might be much more life out there?
Yeah, I don't know that I'm actually on the spectrum. I'm a little bit off the spectrum. I have a slightly unorthodox view, and it's who is deciding that we humans are intelligent, because we're looking for other life forms like us. But who decided that we are intelligent? Well, we did. So we say we're intelligent. Any other life forms out there on Earth that are no, just us. Just us. And so I keep wondering, could there be life forms out there that are vastly more intelligent than we are on a level where they would not rate us as intelligent, consider us not even interesting enough to put on their list of a civilization worthy of their attention? I think about this all the time.
I mean, most people are wondering about what they're going to have for lunch, you know. Okay, so if we loosen our definition of intelligence to include
all big-brained mammals, right? So mammals are a branch of life that only really took foothold by luck because the dinosaurs went extinct by an asteroid. So they had bad luck. But that pried open ecosystems, enabling early mammals to take footholds in places where they previously just would have been hors d'oeuvres for the terrible lizards that we call dinosaurs. So the asteroids are bad for dinosaurs, good for mammals. So we rise up, and now we basically are some of the most intelligent creatures on Earth, from rats and mice and chimps and humans and dolphins and whales and the domesticated animals, dogs and cats. So if that branch never took hold, then mammals would have never risen to what we now see. And that was only 65 million years ago out of a 3.5 billion year history of life on Earth. So the contingency of the existence of our intelligence is something that is not clear would just duplicate in another planetary system. Because it's not obvious that what you need to develop intelligence is as important for survival as other things like, can you run fast? Do you have big teeth? Can you hide? Do you have camouflage? There are plenty of ways that you can dominate your ecosystem and thrive that have nothing to do with what we think of as intelligence. So I don't see why most planets that have life would just have plenty of life just happily coming along, susceptible to the forces of natural selection and evolution, of course, but without intelligence ever arising up. I think there'd be plenty of such places are doing just fine in the galaxy and across the universe. Now, if you do happen to develop intelligence, and you did it earlier ago than mammal intelligence developed on Earth, then maybe you've had 1 billion years to develop intelligence instead of our measly 65 million years from the branch of life called mammals. So imagine a life form that's been developing intelligence far longer than ours. We could end up looking like no greater than worms slithering in the street in the presence of their intellect. I think about that all the time.
I have one final question for you, and
Sure.
that is, if you ever got the chance to meet an alien, an extraterrestrial, what would you say?
Here's what I would do. I would show the alien, I assume they could see, and I would show the alien our periodic table of elements. I would find out how they count. They have got to be able to count. Once we learn how to count, once we learn about the elements, then we do some rudimentary mathematics. Do they have a representation for the value of pi? Pi is very important mathematically and practically. It's practically important. How do they represent pi? Then I compare my representations with them, our representations. And so you build a vocabulary from things we have in common. I'm not teaching them English. That's not happening. And then I would ask, how have you solved these various problems? I would ask for help, because for sure, human civilization in 2016 needs help. So now I would hope that they are benign and kind, because if we were they, we would come upon a civilization less advanced than we are, and we would just round them up into reservations or kill them or enslave them, or, like I said, put them in a zoo as research curiosities. So I would hope they don't treat us the way I know we would treat them.
I think it's just worth taking a step back here to absorb what's been said. First up, intelligent life may not be all that common. There doesn't seem to be much of an evolutionary advantage of having intelligence. Being able to move or razor-sharp vision seems a higher priority. So maybe there are just lots of planets around other stars doing fine without intelligence. And on this line of thought, life itself may be abundant, but perhaps not broadcasting its presence to the rest of the universe. Or maybe we're just worms on the street to other extraterrestrials who've been evolving intelligence over billions of years. Both pretty sobering thoughts. So what would it mean to discover if we weren't alone? Because given the astronomical size of the universe, we're unlikely to ever meet it. So does it really matter? Jim Al-Khalili again.
I used to think that it would it render world religions obsolete? Certainly those religions that their philosophy, ideology is about us humans being special and being created by a divine being that created us in his image, and all the stuff, for example, in the Abrahamic religions. Is that all sort of thrown up in the air if we discover that we're not special? But I think talking to other people, I'm now inclined to agree with them that religions are probably more versatile than I thought. They would roll with this punch in the same way that the more enlightened religions are quite happy to have acknowledged that the Earth isn't the center of the universe, post Copernicus and Galileo. So I think discovering life elsewhere won't do away with religions, but it will certainly, I think, change our perception of our place in the universe in a far more profound way than I think people think now. And I just use it as an example, the false alarm back in the late 90s of discovery of the fossilized microbe on Mars. Bill Clinton went out on the White House lawn and said this will be the most significant discovery in the history of mankind. Well, I wouldn't disagree with him there. I think it would be profoundly important.
How do you at home think life would change if we found life beyond Earth? Do you think we should even be looking for it in the first place? I'd be really keen to hear your thoughts. You can tweet @NakedScientists or find us on Facebook, facebook.com/TheNakedScientists. For me, I think the answer to that question became clear when sat in the sun with Patrick in the park. There were kids mucking around on the swings. And I realised that one of the things we enjoy most, and I suppose what makes us fundamentally human, is that interaction with others. It's what the Christmas holidays are all about, spending time with those you love. And combine that with our curiosity, then the search for life elsewhere in the universe is worth it, despite all the improbabilities of finding it. A huge thank you to all my guests this week. That's Dallas Campbell, Nick Lane, Carol Haswell, Jim Al-Khalili, Stanley G. Love, Paul Meacham, Patrick Short, and Neil deGrasse Tyson. The programme was produced and presented by myself, Greer Jackson. Next time is the best bits of The Naked Scientists with Georgia Mills, so tune in for all the behind-the-scenes gossip and more. The Naked Scientist comes to you from Cambridge University and is supported by the STFC, the EPSRC and Rolls-Royce. Until next time, goodbye from me and the rest of the Naked Scientist team.